Hi everyone, welcome back to Life Technologies YouTube channel, and I hope you're doing well from wherever you're watching from. So this is another episode of our Huawei Lab simulation series. Remember, in this series we demonstrate to you how to configure and troubleshoot different networking protocols or different networking technologies on Huawei routing and switching devices. So if you're interested in learning how to configure, how to manage, how to operate different protocols or different technologies on Huawei routing and switching devices, kindly check out our previous episodes. And also a kind reminder that if you are watching this video and you are yet to subscribe to our channel, kindly hit that subscribe button and stay tuned in for more upcoming videos. So in this episode, we are talking about route distinguishers. And when we talk about route distinguishers, we know that they play a very important role on MPLS, on a network that has MPLS BGP VPN deployed. So the primary function of route distinguisher is to make routes unique, like it's allowing the customer to use overlapping addressing spaces, and then the route distinguisher will be in charge of making these prefixes unique so that we can have communication between customers using the same overlapping addressing space. So the format of a route distinguisher can be different, and that's why we have three classifications of route distinguishers. So we have type 0, type 1, and type 2 route distinguishers. So when we look at, let me use the edit paint. So we know that a route distinguisher will be 8 bytes long. So if I use a text, this one will be 8. So that is the length of a route distinguisher. It's 8 bytes long. And I've mentioned that we have three types of route distinguishers. So let's look at these three different types of route distinguisher and their format. So the first one, we call it the type 0 route distinguisher. So for type 0, the format is like this. We have the first part, which is the type. Then we have the second part. The second part will be the AS number. And then we have the third part, which is a unique number. So for type 0, this one remains the type. Of course, this one will be type 0, which is 2 bytes. Remember, in total, we need to get 8 bytes. And then we have the AS number. So AS number will be here. And this one will be the traditional 2 byte AS number. So this is also 2 byte. And now to make it to 8 bytes, we need to have a 4 byte unique number. So this one will be 4 byte unique number. So this is the format of a type 0 route distinguisher. So the problem with type 0 route distinguisher, especially in a setup where we are multi-homed, is that, for example, in this topology, you can see that we have CE2 and CE2 is connected to P3 and P2. In such kind of a setup, remember the route distinguisher configured on P3 and P2 are the same if we are in a such kind of a setup. So the route that will be advertised from P3 to P2 will be coming with the same route distinguisher. So a RAR will be able to see that route as the same route. So it will perform the best route selection process, and it will only advertise one route towards the remote PEs. So remember, this is the RR, so it will advertise only the best route. So this is the big challenge with type 0 route distinguisher, because imagine we lose this link. Maybe this is the primary link and we've lost this link. It means the route reflector has to recalculate the best route. It has to go through the process again, and it has to re-advertise the route to P1 now using the alternate path, before we can start forwarding traffic. And this one definitely in a big service provider network, it will take some time, which means the services will be impacted. We'll have a downtime when the traffic is switching, when the route calculation is taking place. We are not able to communicate from C1 to CE2. When we talk about type 1 route distinguisher, so for type 1 route distinguisher, we also have the type. We have the 4-byte IP address, and then we have a unique number. So we still have the type, so this one will be type 1 in this field, which will still be 2-byte. And then we have the 4-byte IP address, and now we have a 2-byte unique number. So this is how it looks like. We have the type 1, which will be 2 bytes. We have 4 bytes IP address, and this IP address we normally use the loopback IP of the PE. So, and remember, when you are setting up the network, we normally use different IP addresses as the loopback IP. So it means all the route distinguishers will be having a different route distinguisher because they have unique loopback IP addresses. And then we have the 2-byte unique number that is selected by the administrator. So this is how it looks like. So with this kind of route distinguisher, it means this PE has a unique route distinguisher. This PE has a unique route distinguisher. When they are forwarding the route that are coming from the CE, they will be using unique route distinguishers to forward the route to the route reflector. And route reflector will be able to see these routes as different routes. And all the routes will be propagated towards the remote PE. So the PE will get 2 routes, and this one helps in quick failover, and even we can be able to get load balancing of traffic because the route reflector is able to forward both routes from P2 and P3 will be forwarded towards P1. So P1 already has a route to the prefix that is coming from CE2. So whenever there is a failure, the traffic is able to switch quickly. The failover will be faster compared to when the RR has to perform route calculation again and then share the routes to the remote PEs. So this is how it looks like. Type 1, the 2 bytes, the 4-byte IP address, and then the 2-byte unique number that is chosen by the administrator. So when we look at the type 1, type 2. So type 2, this one still remains the type. We have the AS number. Now we are using a 4-byte AS number, and then we have a unique number. So we have the type, which is still 2 bytes. Remember, we need to make it to 8 bytes. And then we have the 4-byte. Remember, nowadays we have the 4-byte AS numbers instead of the 2 byte. Need to pull it up. And then finally, we still have the 2-byte unique number. So this is how the 3 will look like. So we have the 4-byte unique number, we have the 2-byte unique number, and then we have the 2-byte unique number. So this is how a type 3 looks like. Many times, the one that is mostly recommended is type 1. So type 1 is the format, type 1, the 2-byte number, then we have the 4-byte IP address, and then we have the 2-byte unique number. So type 1 is mostly preferred, especially in a scenario where you have multi-homing connections. So the route reflector or whichever PEs will be advertising the routes directly to the P1, and P1 will be able to install these routes because they are coming in like two unique routes, two separate routes. And then as opposed to type 1 where the route reflector will have two, it will see these routes are the same. It will perform best route selection process, and it will only advertise one route to P1. Whenever there is a failure, the route reflector has to perform the route calculation, best route selection process again before it forwards the route to P1. So there will always be downtime. The failover will take some time before the traffic chooses the secondary path that is available. So when you look at this topology, we have C1. So C1 is connected to P1, which is in our MPLS backbone. AS number is 65,000. We are using OSPF10. And then we have P1, just a provider router. And then we have another provider router that is configured also as the route reflector. It's connected to P3 and P4 and P2. And then we have C2 that is multi-homed to P2 and P3. So the first step that we need to do is to do the basic configurations, and we will do the first implementation using type 1 type 0 route distinguishers. Then we'll be able to verify that the route reflector is only advertising one route to the P1. Once we've done that, we will change the route distinguishers on P2 and P3 to type 1 route distinguishers, and we'll also verify that now P1 is able to receive this route from both P2 and P3 as opposed to the type 0 route distinguisher. So for our configurations, we need to configure the interface IP addresses, we need to configure OSPF, we need to also, remember this is MPLS backbone, so we need to configure MPLS on the interfaces and also activate it on the router itself. And we also need to configure BGP. So we have the route reflector here. So this is our route reflector, and we need to configure BGP between P1 and the route reflector, P3 and route reflector, P2 and route reflector, and ensure that we are able to propagate the routes between the PEs through the route reflector. So we'll configure VPN instance, VPN A on PEs, and then we'll put these interfaces connecting to the CEs in that VPN instance, and we'll also use BGP as our PECE routing protocol. So let me start by configuring P1. So the configuration is step by step so that you are able to master how to do the implementation. So the first thing, I will undo terminal monitor on this router. Then remember, we always have to configure the sysname. So the sysname will be P1, and we can go ahead to configure the interface parameters and also MPLS and OSPF. So let me first activate MPLS so that when I'm configuring the interfaces, I'm also able to activate MPLS on the interfaces. So the first thing, you always have to configure the LSR ID. So we are using the loopback IP as our LSR ID. Then I'll activate MPLS and MPLS LDP for label distribution. So once I've done this, I need to now configure the interfaces. I'll start with interface loopback 0, IP address 1.1.1, mask is 32. I'll configure the interface in my MPLS backbone, so 0/0/0. IP address, it's 10.10.10.0, mask is 31. And I need to activate MPLS and MPLS LDP so that we can be able to exchange the VPN v4 routes with the correct label information. So once I've done this, I can now go ahead and activate OSPF. So OSPF 10, the router ID will be set to 1.1.1. We are all in area 0, and then I will advertise the loopback IP 1.1, and then I need to also advertise the point-to-point IP between P1 and P1 0.1. So that is it. After OSPF, I'll also activate BGP between the PE towards the route reflector. So remember this one is in BGP 65,000. I can configure the router ID to 1.1.1, and then I need to configure the peering session. So remember our route reflector has an IP address of 2.2.2.2, and this is IBGP. So AS number is 65,000, and then I will specify the connect interface. Remember this is IBGP, so I need to specify the connect interface. This loopback 0. I go to IPv4 family VPN v4, and then I do peer 2.2.2 enable. So this is it for the basic configurations on P1. For P1, the configurations are also very easy and straightforward. So I'll undo terminal monitor, system, and then sysname P1. With sysname P1, you can now go ahead and configure MPLS parameters. So LSR ID, it's 5.5.5, MPLS, and then MPLS LDP. Once we've activated MPLS, we can configure interface parameters, interface loopback 0, IP address 5.5.5, mask is 32, then the back-to-back connections. IP address of this interface is 10.10.10.1, mask is 31. I will activate MPLS and MPLS LDP. So if you forget to activate MPLS on these interfaces, your routes will be advertised, but you may not be able to ping or do service tests. So you need to ensure that you activate MPLS and MPLS LDP on all the interfaces. Once I've done that, I'll configure the next interface, which is gig 0/0/1, MPLS, MPLS LDP, and then IP address. It's 10.10.10.8. Just confirm the IP address. Mask is 31. Then I quit. So I've finished interface configuration. I'll do OSPF. PF10 router ID will be 5.5.5. Still in area 0. This is in our MPLS backbone, so I can just use one command and activate MPLS, I mean OSPF on all the interfaces. So I've done that, and that is it for this P. Remember, P router does not establish BGP peering session with the route reflector. So on the route reflector, this is where we need now to configure the BGP peering sessions also towards the PE routers and make it the route reflector. So sysname, this is P_RR. I will activate MPLS, LSR ID. This will be 2.2.2, MPLS, and MPLS LDP. Remember, the route reflector is in the forwarding path, so we need to activate MPLS and MPLS LDP. But if it's not in the forwarding path, then you just need to activate BGP VPN before peering with the PEs. So once I've done this, I need to configure the interfaces. I will start with interface loopback 0, IP address 2.2.2.2, mask is 32, interface gig 0/0/2, the interface connecting to P1, IP address 10.10.10.9, mask is 31, MPLS and MPLS LDP. We have another interface, gig 0/0/0. The IP address will be 10.10.10.2, mask is 31, MPLS, MPLS LDP. And then finally, interface gig 0/0/1. The IP address will be 10.10.10.4, mask is 31, Then I need to activate MPLS and MPLS LDP. The next thing is OSPF configuration. OSPF 10 router ID will be 2.2.2. Then this one I will also use the command area 0. I just use network command. Many times when you are configuring it in production, it's always good to specify the exact networks. You don't have to use the 0.0 that activates all the networks on this router. So you need to be specific. I'm just doing this to save on time. So we have activated OSPF. The next thing that we need to do is we need to configure BGP. So it's BGP 65,000. I'll create group internal, group IBGP, and then call it internal so that we can be able to minimize on the number of configuration command that we need to configure towards the remote PEs. So I'll configure group IBGP connect interface loopback 0. So you see, if we did not have this IBGP group configured, we need to run this command 3 times on all the individual provider edge routers. So this one helps to save on the configuration command that we need to apply on this router. So I'll configure peer. This one will be 1.1.1 for P1. S number is 65,000. And then peer 1.1.1, I'll specify the group to be IBGP. I'll do the same for our other PEs. So this one will be 3.3.3, and the next one is 4.4.4. Then we need to add them in the groups. .3 and then 4.4. So once I've done that, I'll go ahead on the IPv4 family, VPN. Before I need to enable the group. If you can always use a question mark, you can see that you can use the peer group and use the command enable. Then I need to, if I display this, you can see that you have the command enable. So next is to activate the peers 1.1.1 enable, peer 3.3.3 enable, and then peer 4.4.4 enable. And given that we are using the reflect client, so I need to configure the peer IBGP and use the command reflect client. This one has also helped to minimize the commands, because if we did not have the groups, then we need to run this command 3 times on each individual peer. So I can display these. You see the configurations. Display this. You can see all the BGP configuration that we've applied on this router. So once we've done this, we can go ahead and configure P3. So on P3, remember we'll do the verifications later. So I will undo terminal monitor. Then sysname, it's P03. I will activate MPLS LSR ID, which is 3.3.3. Then MPLS and MPLS LDP. After this configuration, I need to configure the interfaces. So starting with loopback 0, IP address 3.3.3, mask is 32. And again, the back-to-back connections, MPLS, MPLS LDP, IP address 10.10.10.3, mask is 31. I'll configure the next interface, which is gig 0/0/2, MPLS, MPLS LDP. I'm starting with MPLS and MPLS LDP so that I don't forget to do these configurations. Many times it's very easy to forget the MPLS and MPLS LDP activation on the interface, and it will actually consume a lot of your time when you are trying to establish why you have issues. So once I've done this, I need to assign the IP address of 10.10.10.6 mask is 31, and I'll go ahead and do OSPF 10. Router ID should be 3.3, which is the loopback IP. Then area 0, I'll use network command 3.3.3. This is the loopback interface and the two networks 10.10.10.2 0.0.0.1 as the wildcard mask, and then we have .6 with the same wildcard mask. So we have OSPF in place. We need to finish with BGP configurations. I need to peer 2.2.2 AS number is 65,000. And again, I need to connect interface loopback 0 IPv4 family VPN v4, and I run the command peer 2.2.2 enable. That is it for our BGP configurations. Finally, we need to do similar configurations on P2. So on our P2, same, I will undo terminal monitor. System name as usual will be P02. I'll activate MPLS by configuring the LSR ID, which is 4.4.4. MPLS LSR ID, MPLS LDP, that is what is pending. And then I'll configure the interface parameters, interface loopback 0, IP address 4.4.4, mask is 32, interface gig 0/0/2, IP address will be 10.10.10.5, mask is 31. You activate MPLS and MPLS LDP. Then interface gig 001, MPLS LDP, and then IP address. This one will be 10.10.10.7, mask is 31. And we do OSPF configuration. So OSPF 10, router ID will be 4.4.4. Area 0, we do the network commands, starting with the loopback. And then the next network command for the interconnected interfaces in MPLS backbone. And finally, the interface between P2 and P3. Finally, we need to do BGP configuration. So it's BGP 65,000. Peer 2.2.2.2 AS number 65,000. Then peer 2.2.2 connect interface will be loopback 0. You always have to specify this for iBGP, or less it will use the outgoing interface. So once I've done these BGP configurations, I need to activate in the VPN v4 family to enable. So we finished configuring OSPF. Let's test our reachability. If I display OSPF peer brief, you can see that we have the adjacencies. Are we able to ping 3.3.3? We are able to. And then 4.4.4. It's also okay. And finally 1.1.1. So it means the communication is okay. We expect the BGP peering sessions to come up. BGP VPN v4 all peer. You can see that we have BGP peering session from our route reflector towards the PEs. So the next thing that we now need to do is to start configuring the PECE connectivity. So first thing we need to do is to configure a VPN instance on the PEs. So I will undo terminal monitor again. So you run the IP VPN instance. We are using VPN A. So once you've configured VPN A, you need to configure the route distinguisher. So the first part we are using the normal route distinguisher, which is type 0. Remember, type 0 route distinguisher, you have AS number colon unique number. So you will have to configure the AS number, which is 65,000 colon, maybe I can use 100 or any unique number that I choose. And then we need to configure the VPN target. So for VPN target, I'll use 100 colon 1 for both import and export. So remember, these are the two important things that you need to configure when you are doing VPN instance or VRFs. So you can see that these are the configuration, and this is a type 0 route distinguisher. We have the AS number colon a unique number that has been selected by the administrator. Once we've done this, we need to configure the interface facing the customer and bind the VPN instance. So let me move this to the right. So we start with the interface gig 0/0/1 IP binding. This is the command you use to bind a VPN instance on an interface. VPN instance, it's VPN A. Then I'll provide an IP address of 172.16.16.4. Mask is 31. Once I've done that, I'll go ahead and configure BGP. So it's still BGP 65,000. IP v4 family, we are now configuring in the VPN instance VPN A. Then I just need to specify peer 172.16.16.5. AS number will be 200. So this is it on this PE. The next step is to now configure PE3. So we are also using the same format of route distinguisher. We are using the type 0 route distinguisher so that we can be able to demonstrate why type 0 route distinguishers are not the best and why we recommend type 1 route distinguishers. So on P3, we need to also configure IP, VPN instance, VPN A, and configure a route distinguisher. So I will configure the same route distinguisher on P3 and P2. So I'll use route distinguisher 65,000 colon 200. Remember, the VPN targets need to be the same so that we can be able to exchange routes between the PE. So I will use the same route target that I've used on P1. Once I've done this, I'll go ahead and configure the PECE connection. Gig 0/0/0 IP binding VPN instance VPN A. The IP address will be 172.16.16.0. Mask is 31. And then we configure BGP, so it's BGP 65,000. And then IPv4 family, VPN instance, VPN A. I specify the peer 172.16.16.1. AS number is 300. So that is it on this P3. I go ahead and check on P2. So P2 same. I'll configure, I can even copy the configurations for the route distinguisher on this router. So if I display, this is on P2. Display current configuration. You can see the configurations of the route distinguisher down here. Where is it? This is P3, P3 actually. Display current configuration. So you can see the configuration of the route distinguisher. I'll copy the same so that we have the same route distinguisher. On P3, this is P2. I'll paste. If I display these, you can see the configurations. And then I'll configure the PECE interface. IP binding, VPN instance, VPN A. I need to configure the IP address to 172.16.16.2, mask is 31, and finish with BGP configuration. So it's BGP 65,000, IPv4 family. It is VPN instance, VPN A, and specify the peer 172.16.16.3 AS number will be 300. So once I've done this, I'll go ahead and now configure the CEs. So on the CEs, we just need to configure the interface facing the PE and activate BGP. On this router, we'll be creating a loopback IP with an IP address of 100.100.100/32 and advertise it in BGP. On the other side, we'll also do the same, 200.200.200/32 so that we can be able to test the connectivity between the two routers. So on C1, very simple configurations and two terminal monitor, and then I'll configure the sysname to CE01. I'll configure the interface loopback 0, IP address is set to 100.100.100.100, mask is 32, quit. And then interface gig 0/0/0, the IP address will be 172.16.16.5, mask is 31. And then we finish with BGP configuration. So it's BGP 200. We specify the peer 172.16.16.4. AS number is set to 65,000. That is it. We go to let's advertise the network so that we finish the configurations here. 100.100.100.100 network mask is 32. And then on CE2, we also need to do the same configurations and do terminal monitor. This name, we give it CE02. And again, we need to configure interface loopback 0. IP address will be 200.200.200.200, mask is 32. Quit and configure the interface facing the PE. This will be IP address 172.16.16.0. AS number is set to .1, mask is 31. We are yet to start the BGP configuration. Interface gig 001. The IP address will be .3, mask is 31. Then BGP 65,000. On this will be 300. Peer, we set the peer to 172.16.16.0. AS number will be, what is it? AS number will be 65,000. We do the same for .2. Display this, and then we advertise the network 200.200.200.200, mask is 32. So that is it. We finished our configurations. We can now move to the verification stage. If I check the BGP display BGP peer, it's still idle. Let's see whether we can ping 172.16.16.4. We are able to ping, display these 65,000. Looks okay. Let's check the configurations on this router. Display these. S number is set to 172.16.16.5. That is okay. Display IP interface brief. This is set to .4, which is okay. Display BGP VPN v4 all peer. So you can see that now the peering is established. If we go back to C1, we also expect to be having a peering relationship that is up. You can see it's established. On C2, we do the same, display BGP peer. The relationship is established. On P3, display BGP VPN v4 all peer. You can see that we have a peering to the route reflector, and we also have a peering to the CE. So on the route reflector, I can display BGP VPN v4 all peer. You see that we have 3 peering sessions up towards the provider edge routers. So after this, remember that we've created a network on both C1 and C2. And if we try to see, if I display IP routing table, of course, this is the reason why we are using the VPN, so that we are able to isolate different customers into different VPN instances. So I need to specify the VPN instance VPN A. We are able to get this prefix that is coming from C1 on provider edge router 1. If I check on provider edge router 2, display BGP VPN v4 all routing table, display IP routing table VPN instance VPN A, you see that we have the prefix that is coming in from the CE side. On P2, we also have the same, display IP routing table VPN instance VPN A. You can see that we have this prefix that is coming in. But when I check on the route reflector, there is something that we need to do on the route reflector for us to be able to get these routes. If I display BGP VPN v4 all routing table, you see that we don't have any routes on the route reflector. The reason or the issue is on the route reflector we haven't configured any VPN targets or VPN instances, so it's not able to learn the routes using the VPN v4 parameters. So what we need to do is to disable the VPN targets. I'll do BGP 65,000. If I display this, you see that under the VPN v4 we have policy VPN targets, which means this router has to check the VPN targets before it can install the routes in its own routing table. So what I need to do is I'll go into the IPv4 family VPN v4 and undo VPN target. Undo policy VPN target. Once I've done that, because even you could see that the routes are not on P1, we are not getting this prefix 200 or 200 or 200, we were only getting 100 or 100. Even on P3 it was the same, we are not getting 100 or 100, we are only getting for the connected CE. So when I check on this router again, you can see that we still have 100 or 100 or 100. It will take time before we can start getting the 200 or 200. So on the route reflector, display BGP VPN v4 all peer. So you can see our peering is up, display BGP VPN v4 all routing table. You see that we now have routes. We are having one route with this route distinguisher and another route with this route distinguisher. So this is the one that is multi-homed. You can see that yes, we are getting both from P2 and P3. Let's check on P1. P1 still only 100 or 200 or 100. I display this again. Display BGP VPN v4 all routing table. We are getting 100 or 200 or 100 only. Let me check the configurations unless I forget to activate MPLS on one of the interfaces. So you can see the loopback IP, it's okay. This interface is configured properly. We go to the P router, display current configuration. The MPLS LSR ID is configured. When you check on these interfaces, we have MPLS and MPLS LDP configured. So this is okay. MPLS, MPLS LDP. Let's check on the route reflector, display current configuration. We also have MPLS and MPLS LDP activated on the interfaces. We can check on C1. If I display IP routing table, you see that we only have 100 the directly connected. On this one, display IP routing table, we also have 200 or 200. Let's check again the route targets. Display current configuration. You see the route target is set to 100:1 for VPN A. On P3, display current configuration. 100:1 is set as the route target to display IP routing table. Display current configuration 100:1, the route distinguisher, it's okay. Do we have MPLS LDP activated on the interface? Gig 002, gig 001. This is okay. Let's check on P3. Display current configurations. MPLS and MPLS LDP is activated on the interfaces. Let's check on the route reflector again. Display IP routing table, or display BGP VPN v4. Display BGP VPN v4 all routing table. You can see that we have the two routes. This one, the one from 3.3.3 is preferred. We need to check whether this route is advertised towards the PE. So on this P1, if I display BGP VPN v4 all routing table, we only have 100.100.100. Display these. We need to see why it's not installing the routes. We can check whether the route is being advertised. Display BGP VPN v4 all routing table. PI is 2.2.2.2 received routes. So we are not getting any received routes from there. Let's check advertised routes. Advertised routes, we are able to advertise this prefix. On the route reflector, display these. If we check display BGP VPN v4 all routing table, peer 1.1.1 advertised routes, see that we are not advertising any routes. We've activated the peering session. Let's check our BGP configurations again. So you always have to be able to troubleshoot. We need to IPv4 VPN v4 and then peer 1.1.1.1 group IBGP. We do the same for the other groups. And then 4.4.4, so we need to activate the groups. This one, this one, this one. 4.4.4. Remember, with the IBGP split horizon is if the RR gets a route from, if this one is not acting as a route reflector and it gets the route from P3 and IBGP, it will not advertise to other IBGP neighbors. So when I check on P1 again, I expect to get, let me run all routing table. You can see that we are now able to get the routes. On P1, you see that we only have one route, which is coming from, it's coming from VPN instance VPN A. We have one route, and this one route has 200.200. The next hop is 3.3.3.3. So we are not getting the one that is coming from 4.4.4. If I check on the route reflector, display BGP VPN v4, all routing table, peer 1.1.1.1 advertised routes. You can see that we are only advertising one routes, the best route from to this destination network 200.200.200.200. So we are not advertising the redundant or the backup path. So if we ping, we should be able to ping. If I ping -a, this one will be 100.100.100.100 mask. So maybe I need to show you first that this router has the IP routing table. You can see that it's getting 200 to 200. So ping -a, we source from the loopback IP that we've configured, and then we ping 200. I also need to count a count of 100 or 1000 -a. This is 200.200.200.200. So we are able to communicate from C1 to C2. So the communication is continuous. What if we lose the second path? This one may not demonstrate correctly because this is a very small network. But you can imagine a service provider network with so many routers, and a route reflector is normally maybe located in a very far location compared to the PE routers, and it's connecting so many other routers in the forwarding path. So it will take time for that new update from BGP to be propagated from the route reflector towards the PEs. But from the what we've seen, you can clearly see that this router is only advertising this prefix from 3.3.3 towards the PE. So on the CE, the ping is still going on. What I can do is I can shut down. How many did I ping? I did 1000. When I shut down this interface gig 0/0/0 and shut down that interface, you see that on C1 we have a packet drop. So this is just one packet that has dropped. But if it was in a big network, then you expect that this will take time before the route is propagated, even before the route reflector is able to calculate the route, select the best path using the BGP attributes, and then forward it towards the destination. So now if you check on the RR, we were advertising this one route. If you check now, we are able to advertise the backup path that is coming from PE2. So now what we need to demonstrate is we will go ahead and configure type 1 VPN route distinguisher on P2 and P3 and show you that now the route reflector will be able to advertise the two routes towards the P1, and the communication will now be much faster. The failover will be much faster compared to when we are using type 0 route distinguisher, because both the routes will be forwarded towards the Ps, and the route reflector doesn't have to do anything whenever there is link failure towards the multi-homed CE. So on this P3, I need to first delete the route distinguisher because I'm not able to change the route distinguisher. So I will undo VPN instance, VPN A. It will take some time. Now, if I do IP VPN instance, VPN A normally takes some time before it's cleared. So we give it some time, but I can also delete the VPN instance on this router. Quit, undo VPN instance, undo IP VPN instance, VPN A. So on P3, we've already taken effect. So for the route distinguisher now, I will use the loopback IP. So I will set 3.3.3 colon 100 or 200, any random number that I choose. And then route target remains the same, the VPN target. So the VPN target will still be 100:1 so that we can exchange the routes quit. So one thing that I need to do, I need to reconfigure the parameters. So gig 0/0/0. I'll do IP binding VPN instance VPN A and IP address 172.16.16. 0, mask is at 1, and quickly I will do the BGP configuration 65,000 IPv4 family VPN instance VPN A, then I specify the peer 172.16.16.1 AS number is set to 300. That is it. Let me unshut the interface so that the peering can come up and do shutdown, and we can do the final verification. On this one, I do the same IP VPN instance, VPN A. I need to configure the route distinguisher. You can see the different formats. So I will use 4.4 colon 100, which is the unique number, and then VPN target. We use the same VPN target 1. Finish with the interface configurations, and finally BGP. I'll undo IP binding, VPN instance, VPN A, IP address it's set 172.16.16.2, mask is 31, and finally BGP 65,000 IPv4 family VPN instance, VPN A. The last command is 172.16.16.3. AS number is set to 300. So we can wait for the BGP peering session to come up, display BGP peer. To take time, but you can see the first one is already up, so we wait for the second peering to come up, because this is a multi-homed CE with 2 connections to 2 PEs. So it takes around 40 seconds to be established. We give it some more time. It's now inactive. It's now established. So once we have our BGP session established, if we again check on this display BGP VPN v4 all routing table, you can see that we are getting these prefixes. If I check on P1 display BGP VPN v4, I can just recall the command. You can see that we are now getting the 2 prefixes. We were getting only one previously from P3. And whenever there is an issue, we need to wait for the route that is coming in from P2 to be propagated from the route reflector. But as of now, you can see that we are getting the 2 prefixes. One from 3.3.3 and another one from 4.4.4. And on the route reflector, even, you are able to see that we were only advertising 1.1.1. So let's see if we check this. Which one was this? You can be able that we are able to advertise one from 3.3.3, and we are also advertising one from 4.4.4.4. So whenever there is an issue, the traffic failover on P1 will be very fast. It just needs to pick the available path that was shared from the route reflector, and it's able to get the 2 updates from the route reflector. So the failover will be very fast when we are using the type 0 route distinguisher, or another way it's just to ensure that you configure 2 separate route distinguishers on the PEs. So we can demonstrate that our ping should still be going on. So on this I can do shutdown. So again, this one may not demonstrate clearly how many packet drops we get, but if it was in a bigger network, then it will take time for the propagation of the routes to happen again. But with route type 1, the route will already be available on P1, so the failover will be much faster and less downtime will be encountered when you are using type 1 route distinguishers. So these are the 3 types of route distinguishers. We've talked of type 0. So for type 0, you use the, if we use the diagram again, for type 0, you have the type, which is 2 bytes. And then you have the 2-byte S number and 4-byte unique number that is assigned by the administrator. With type 1, you have the 2 bytes of the type, which will be type 1. You have the 4-byte IP address, and this IP address is normally the loopback IP, so it will always be unique. And this is what is recommended for a production network. So type 1 is always recommended to be used on a production network. And then you have the 2-byte unique number that is given by the administrator. For type 2 also, you have the type, which is 2 bytes. Remember, a route distinguisher will be 8 bytes long. Then you have the 4-byte S number, and you have the 2-byte unique number that is assigned by the administrator. From the configurations you've seen, it's very easy. You need to configure OSPF, you need to activate MPLS, you also need to configure BGP between the PEs, either meshed, or you can have a route reflector in the network, which makes it more scalable. And again, you need to configure the VPN instances and ensure that your PEC routing protocol is working. And yeah, you are good to go. You can demonstrate or you can simulate how to use the different types of route distinguishers and which one will be most efficient for a service provider networks. So I hope you've enjoyed this session. I hope you've learned something, and I hope you've liked it. If you've done so and you are yet to subscribe to our channel, kindly hit that subscribe button and stay tuned in for more upcoming videos. Thank you so much for watching, and see you in our next episode. Bye.